of metals and non-metals. So first of all, metals, what will happen? Okay, so what do you expect when a metal, suppose M, reacts with oxygen? What do you expect? It will generally or most commonly form an oxide, which can be either M2O, MO, MO2, anything, depending on the valency of M. So when Na reacts with O2, it forms Na2O. No. And when K, actually when Na reacts with O2, it can form another oxide. It's not necessarily Na2O. It can form Na2O2. This is called sodium oxide. And this is called sodium peroxide. And the radical, generally we have Na2 plus and O2 minus. Sorry, no, Na2 plus, what am I writing? Na plus and O2 minus, and so we have Na2O. But in this case, we have Na plus and O2 2 minus. This is a radical, and this is called this peroxide radical. So when Na reacts with O2, forms Na2O, it can also form Na2O2 depending on the conditions. And or if you have K reacting with O2, it forms K2O, which is potassium oxide. It can form this, which is potassium peroxide, or it can form this also. And this KO2 is known as potassium superoxide. And here we have the radical O2 minus, and we have K plus. Now only this K can form superoxides. Na cannot form NaO2, and why it cannot form, that we will study later. But just for your information, you also have peroxides and superoxides along with these normal oxides. But we will not concentrate much on peroxides and superoxides. What our area of concern is just oxides, normal oxides. So they can be Na plus O2 giving Na2O. You can have calcium plus oxygen giving what? CaO. You can have aluminium plus oxygen giving Al2O3. So this is 4Al plus 3O2 gives 2Al2O3, and this is sodium oxide, this is calcium oxide, and this is aluminium oxide. Now, you know, this oxides, you see, when they are formed, they will not form at the same rate, or they will not form with the same, what do you say, some oxides will be very vigorous in their formation and some oxides will not be very vigorous in the formation. Like sodium, if you just have a sodium piece out in the open, it will just react with the oxygen in the atmosphere and it will form sodium oxide and it will just get burnt away. But aluminium, you will have to heat it a little bit, you will have to hold it over a flame to form oxides. We will see why later in this chapter, but now for now's concern is that all these Na2O, CaO, MgO, Al2O3, all these oxides can be considered as basic oxides, isn't it? Because Na2O will form NaOH when dissolved in water, CaO will form, or I'll write it, Na2O will form NaOH when dissolved in water, CaO will form CaOH whole twice when dissolved in water, MgO will form MgOH whole twice, and Al2O3 will form AlOH whole thrice. So all these are bases. So these are all basic oxides because they react with water to form bases. And on the other hand, non-metals like carbon, if you burn it in oxygen, it produces carbon dioxide, and carbon dioxide is essentially an acidic oxide because carbon dioxide will react with water to form H2CO3. This is under very high pressure, but it does form H2CO3, which is carbonic acid, and it is an acid. Similarly, sulfur will react with oxygen to form SO2, and SO2 will react with water to form H2SO3, not 4. This H2SO3 is known as sulfurous acid. This not sulfuric acid. SO2 forms sulfurous acid. SO3 forms sulfuric acid.